Good morning.
Good morning, Miss Fuji.
Well, we've learned a lot about magnets so far. Let's just review. What did we learn about magnets so far, boys and girls? What do we know about magnets? I'm going to give you 1 minute to let your partner know. Take turns. For instance, if Maya is my partner, I would tell Maya something that I've learned about magnets, and Maya will tell Miss Fuji what I've learned about magnets. We'll go back and forth. So in just a minute, I'm going to ask you to share with your partner what you've learned about magnets so far. Okay, 1 minute. Go.
That magnets have more magnetism at the poles than in the middle. I learned that magnets and they're opposite, they stick.
But then I went back this morning and looked at it again, and I realized
Some of the bar magnets
At poles?
have poles.
Where are the poles?
At the end of the bar magnet?
Okay. Is it only on the bar magnets?
No.
So where would it be on the other magnets?
At the end of the magnet?
The ends? Okay.
some videos and we had done some discussion. We did some readings and so on. So they had some basic knowledge.
Magnets stick to steel and iron. Some magnets can move a paper clip under a tongue depressor. Some magnets move paper clips under paper, and some book covers.
Where on the magnet were the paper clips?
The paper clips mostly would stick to the poles because the poles have more magnetism than the sides.
What does magnetism mean?
Magnetism means how strong the magnet is and how strong the magnet can be.
And where is it found again?
The most magnetism is mostly found at the poles of the magnet.
Okay, great. Betsy, do you have something to say about magnets? What have you learned about magnets so far?
Magnets are strong enough to stick to kind of thick things.
What's another word for sticks too?
Attract.
Attracts, so the magnet attracts. What are some things that the magnet attracts to? Think about in the classroom. Thank you. Gave you a chance to talk about what you've learned about magnets. So let's share as a class. What are some things that you've learned about magnets? Tiana?
Magnets attract to steel and iron.
To steel and iron? Okay. What are some things that are made out of steel and iron?
Paper clips.
Paper clips. And Sarah?
I know that a bar magnet, if you put SS together, they won't stick.
What's another word for stick?
Repel.
Attract.
They will not repel.
Okay. So if you put a south and a south together with the bar magnets, will it attract or repel? What would attract, Angelina?
S and N.
So a north and a south would attract. So the opposites would attract. Okay, good. What are some other things that you've learned about magnets so far? Maya?
They have more magnetism at the poles than the middle.
Then the middle, so the most magnetism is at the end of the poles. And what is magnetism, Maya?
The strongness of the magnet
So how strong the magnet? So most of the strength is where?
at
On
the
magnet.
poles.
At the poles. Okay, do you agree or disagree with mine? And we learned that the poles have the most strength. So what do we do? Well, how do we test that out? Daniel.
Give us some paper clips and we try to put in the pole.
And where do the paper clips? Where do the paper clips mostly go to?
The pole.
The poles. And I like the term that Daniel used, poles. He didn't just say the ends of the magnet. He said the pole. Very good. Well, today, boys and girls, we're going to look at some other magnets. We've already looked at the bar magnet. We also looked at the rubber magnet. You know what? Let me go back to the rubber magnet. What do we do with the rubber magnet? The square-shaped magnet here. What do we do? They look different. What do we do with this one, Justin?
Put it on one of those walls and it attract.
It attracted to the walls, but do magnets attract to walls usually, boys and girls?
No.
Which wall did it attract to?
The doorway.
Oh, the door here. Sandra, could you show us where the magnet attracted to? It attracted to that wall, but Sandra, why don't you try this wall here then? It didn't attract to that wall. Why did it attract to that wall and not this wall? And Charles,
If there's an earthquake, then we can go over there and we will be safe.
okay, if there's an earthquake, we can go to the doorway. But why does the magnet stick on that wall? Attract to that wall instead of this wall here? Does the magnet attract to steel and iron?
Yeah.
Okay. We're not only going to look at these two magnets today, we're going to look at two other magnets. And the magnet we're going to look at looks like this tiny magnet, and this magnet here. Which one do you think is called a horseshoe magnet?
That one.
Which one? Point to it. Which one do you think is called a horseshoe magnet?
The one on the left.
The one to my right and to your?
Left.
Okay. Well, it is. It does look like a horseshoe. And we're going to actually investigate this magnet too. It's called a horseshoe magnet. And also this magnet, which is called a rod magnet. Can you say rod magnet?
A rod magnet.
Horseshoe magnet.
Horseshoe magnet.
Now let's just review here. Do you remember this one here?
Bar magnet. Rubber magnet.
Very good. Well, in just a minute, I'm going to have the materials gatherer go to the back table to gather one of each magnet. You're going to get the rubber magnet, the bar magnet, the horseshoe magnet, and also the rod magnet. Okay? So raise your hand if you're the materials gatherer at your table.
Go ahead.
Okay? Just raise your hand. Okay. There should only be two at each table. Okay? It's Angelina, right? Okay. In just a minute, I'm going to have you go to the back table, get one of each magnet. Then, while you're waiting, I would like for you to look at each of the four magnets and tell me what's different about them. I'd like for table 1, the materials gatherer, please. And for table 2, the materials gatherer. Okay, can I have table 4, please? Table 5.
Do you think this would attract? Do you think this would attract like a paper clip?
Or maybe it might attract to the part of your glasses right there because that looks like it could be metal or iron.
I think it will attract to this and paper.
I know Miss Fuji looks at this one a lot. Do you think that this would lose a little magnetism if people dropped it? If they dropped? Okay.
Do you think this will attract to your earrings?
The metal part, the golden part?
Two of them have the south and north, but these two don't.
And this one's the smallest one.
And they're both black. And two are red, two are black.
How about, Justin, just by looking at the magnets, what differences do you see?
One's small.
Oh, small. And which one's the smallest here? And which one's the largest? So what can I say is different? They're all different sizes. What else can you say is different?
These two are the same because they both have south and north. Here, and red, like to the little and red.
Smallest, medium, big, large. There it goes.
This one, I think it has a little more magnetism than all of the rest because this one has more parts than all of these.
So more parts?
It has more magnetism because it has more parts of magnet.
Oh, there's more of the you mean it might be the largest one here? Well, just by looking at the magnets here, what do you think is different about them just by looking at them?
They're different sizes.
They're different sizes. What else?
They're different colors.
Different colors. What else could you tell me?
These two, they're kind of similar because they don't have any letters on them.
Oh, they don't have letters. What letters are you referring to?
It doesn't have N or S.
N and S means the poles. Do you mean these has poles? So you don't think these have poles?
No.
You don't think they have poles?
No.
Do magnets have poles?
Yeah.
Some of them.
Some of them? That's interesting. It's something probably we have to investigate. But just because it doesn't have N or S, do you think it doesn't have poles? Or do you think it just doesn't have it labeled?
I think it just doesn't have it labeled.
That's interesting. Okay, good.